Today we are going to look at selecting a sample size for estimating a proportion. So we've got that fast food manager from the other example wants to estimate the proportion of customers who have tried the new sandwich. She wants a 90% confidence interval for the proportion to have a half-length of 0.05. So for example, if the proportion turns out to be 42%, a 90% confidence interval will be approximately 0.42 plus or minus 0.005. So how many customers need to be surveyed? I've already put the range names in for these here, so let's just get right to it. So the desired half-length is going to be 0.5. The proportion that tried, since we don't really know, we're just going to use 50% because it's the most conservative estimate that we can have. Confidence level of 90%, and we can calculate out our alpha. Now let me show you another way to calculate out alpha, and you can kind of do this with, even if we go back to the last one, you would be able to do it with this one too. Instead of using our confidence level, we're going to actually calculate out alpha. So before, and I'll do it over here, the way that we've been calculating this is we've gone to the norm, the inverse, and so the probability, we've said the confidence level plus 1 minus the confidence level divided by 2, and that's fine. That gives us the answer that we want to use. No problems at all. So we can look at this and say the alpha. Well, if our confidence level is 90%, that means our alpha is 10%, and so we can go and calculate this out. Norm.s.inv, and so now the probability would simply just be 1 minus the alpha divided by 2. We've even been labeling them alpha divided by 2, and it'll give us the same answer. So just another way of doing things. So our required sample size, what are we going to do? Well, once again, we'll take a look at it, and we'll type in our equation. So z alpha over 2, we're going to divide that by our desired half-length. And then we're going to do it the square of our desired half-length. So z alpha over 2 divided by the desired half-length. And actually, we want to square that whole thing, not just the numerator. Excuse me, not just the denominator. Gonna get my terminology right there. And so that's z alpha divided by that, and we're going to multiply that by our proportion estimate. So we'll throw another set of parentheses in there. Going to multiply that by our proportion estimate, and then multiply that by 1 minus our proportional estimate. Close that off. Let me make sure that my parentheses are all in the right spot. And okay, so we'll hit enter. And so 270.5, once again, we can't have a half a person, so we're just going to go round up. We don't want to round down, because if I round down, it will be less than that confidence interval, because I'll be taking a half a thing out. So we always want to round up. 0. That 0 is the amount of decimal places. So we need 271. So in this case, to get a 90% confidence interval with a maximum half-length of 0.05, and that's maximum half-length because since we went up, it's actually going to be a little bit less than that, but that is fine. The manager's going to need to sample at least 271 customers. And there we go. If there's any questions, let me know. Otherwise, I'll see you next time.